An Android project has a specific structure with a set of directory and file names that are always the same. The directory structure will differ depending on whether a project is created from the command line or using Android Studio. I'm going to focus on the structure created and maintained by Studio. I'll start by opening an existing project that's a part of the exercise files. I'll choose Open an existing Android Studio project. Then I'll go to my desktop. In Windows, you can type Desktop, and the Open Project dialog will go there. On Mac, just find your desktop using Finder. From there, I'll go to my exercise files, then to the Fundamentals directory, and I'll open the project Project Structure. This project has exactly the same structure as the Hello World app that I created earlier in the course. When you open any project from the exercise files, you'll start with an empty screen, but you can get to the project view by clicking the tab. When you open the project window shows a view named Android. This shows you the most important files and folders that you'll deal with as a developer. But to see the raw directory structure, change to the project view. Then from there, open the app module, and then the source folder. And you'll see two subfolders named Android Test and Main. The main folder contains your Java code and your other resources. You'll see that there's a file called androidmanifest.xml. The manifest file defines the app package and then has an application element. The application element defines things like the launcher icon, that's the graphic that's displayed on the device's home screen, a label, a theme which defines the appearance of the app, and then definitions of the app's activities. In addition to activities, you might see permissions in the manifest. The Java folder contains all of your Java code. A very simple app might have just one Java class, named Main Activity. The Main Activity class extends a superclass, which in a brand new simple Android app is called Action Bar Activity. This Main Activity class is registered in the manifest. We have an activity element that points to the Main Activity class. As with the application, there's a label attribute, and that defines the string that appears to the user to identify the app. The activity element also contains an intent filter element, and this defines how the activity can be used. When you see an activity that has an action of main and a category of launcher, that's the first activity that will show up when the user launches the app. Going back to the project window, the RES folder contains your app's resources. If you have any graphical files that are displayed, those will appear in the drawable folder. A simple default app doesn't have anything there. But the launcher icons, again, those are the graphics that appear on the launcher screen, are stored in these folders, named MipMap. In older versions of the Android SDK, the launcher icons were stored in the drawable folders. They're now stored in the MipMap folders, and I'll talk about the differences between those folders and the differences between drawables and MipMaps later on in the course. The drawable and MipMap folders can either have single copies of each graphic, or they can have various versions of the graphics that are designed for different pixel densities. For example, MDPI stands for medium pixel density, HDPI for high density, XH for extra high, and XXH for extra extra high. It's up to the framework to decide which version of a graphic will be used for any individual device. You can learn more about common devices and their pixel densities by going to the Android AVD Manager. Notice that a Nexus 5 is labeled as an extra extra high DPI device. The Nexus 6 doesn't fall into one of the standard buckets, but it falls somewhere between extra extra high and extra 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 high. And devices with smaller screens and lower pixel densities will use other versions of the graphics. The Resources directory also has subfolders that start with the word Layout. Initially, there's just one Layout folder, but just like graphics, You can create multiple layout folders that are marked for different screen sizes and resolutions. This very simple Android app has a single file in the layout folder, and that file defines the appearance of that screen or layout. A layout file is an XML file. You can look at it in WYSIWYG or What You See Is What You Get view, or you can click on the Text tab at the bottom and see the raw XML. I'll double-click the tab at the top so we can see exactly how the XML is laid out. Again, we'll talk about the details of layout files later in the course. Resource files are compiled at runtime, and they're represented by a generated Java class that's simply called R for resources. You address the items in the resources folder through IDs that are assigned during that generation process. But you can also add uncompiled assets to a project. They should go in a subfolder of main that's always called assets, spelled with all lowercase. This folder, along with all the others, is defined in the project's IML file. And the IML file is right here. You can create the assets folder by going to the main folder, right-clicking and choosing New, Directory, and just name it Assets. And then any files that you drop into that folder will be included when you package your app for distribution. The build generated directory contains classes that are generated automatically when you build your app. One of the most important is simply named R. I'll find it by pressing the Shift key twice and typing R. Then I'll go down to my classes list and I'll choose the R class that's a member of my app package. It's critical that you don't try to change this file. It'll be automatically regenerated as you do your development. It contains nested classes and fields representing resources that are bundled with the application. A new project would, for example, have a field named IC_launcher that points to the launcher icon. And as I mentioned previously, that icon can be found in the MIP_map directory. While you develop in Android Studio, you're always running a service in the background that's watching that directory and its subdirectories. And whenever you add or change a resource, such as a graphical file or an XML file, this R class is automatically regenerated. The libs directory here is empty. If you want to add any Java libraries, that is, jar files, you would place them here and then mark them as a library so that they're included in your project's class path. You'll see that there's also an external libraries folder down here, and it includes pointers to the API platform that you're using. I'm using API 21 for Android 5, and also pointers to the support libraries that provide various capabilities for older versions of Android. So that's a look at the basic structure of an Android project. Again, you won't deal with a lot of these files on a day-to-day basis, and that's why the Android view is available. It intentionally ignores all the files that are just there to manage Android Studio and the project structure, and lets you focus on the files that you work with the most: your manifest, your Java code, your resources, and your Gradle scripts that are used to manage the build process. Android Studio projects are built around the Gradle build system. To demonstrate this, I've opened a project from the exercise files called Gradle Scripts. I'll go to the project window, and then I'll see a Gradle Scripts folder under there. All Android Studio projects have the files that are contained within this virtual folder, and you can see this virtual folder that collects all the files together when you're in the Android view in the project window. When you create an Android Studio project, it's populated with 2 Gradle scripts and some other configuration files. I'll start with the file local.properties. It's in the project root folder. A brand new copy of this file indicates the location of your Android SDK. If I have multiple copies of the SDK, I can reset this value for this project, but this option, as with many others, can be set through Android Studio's user interface, so you don't have to be working in the file itself. For this file, I can go to the project window and then choose the project itself. Then go to the menu and choose File, Project Structure. And the very first option is the Android SDK location. If I change it here, that'll change the local.properties file. You can also change which version of the Java Developers Kit, or JDK, you're using. I've installed the most recent version of Java, Java 8, as of the time of this recording. And when I installed Android Studio and created this project, the JDK location was set automatically for me. On Windows, you might need to set an environment variable named Java_home and set it to this location. But on Mac, it should find it automatically every time. If I want to use another version of the JDK, I can set it here. By default, the SDK directory is the only value that's put in the local.properties file. I'll return to the Android view, to the virtual folder Gradle Scripts, and I'll open the next file I'm interested in, Gradle.properties. This file determines a lot about how Gradle behaves during the compilation and packaging process. Everything is commented out by default, and there are comments here about JVM arguments that manage memory for Gradle. Those apply to Gradle, the build system, and not to your app on the Android device. You can look at the references that are indicated in the comments to learn more about this process and how to configure it. For basic Android apps, you can leave this entire file's contents commented out. Next, there are two build.gradle files. The first one is in the project folder. It's the top-level Gradle file. Typically, you won't have to make any changes to this file. It has two references to a method named jcenter. That method is used to manage something called dependencies, and I talk a lot more about dependencies in the course Android Studio Essential Training. Next, there's a class path. That indicates the package and version of the current Gradle plugin. Again, typically, you don't have to change this value. Although, if you upgrade Android Studio to a newer version and then reopen this project, you might see that this value is changed for you. The other Gradle build file is in the app folder, known as the module folder. This file is used to configure a lot about your application. This is where the application ID is set on line 8 in this file. It's also known as the app package. It's the globally unique string that identifies your app to the rest of the world. This is also where you can configure the minimum SDK and the target SDK. The min SDK version, set on line 9, indicates the oldest version of Android where this app will be supported. This will determine whether your app shows up when somebody looks for it on Google Play or another app store. If somebody has an older device that doesn't have at least Android 4, this app wouldn't show up at all. The target SDK version is the version of the SDK you're using to compile and package your app. And most of the time, you're best off setting it to the most recent version of Android. I have my target SDK set to 21, which stands for Android 5, Lollipop. This file is also where you set the app's version code and version name. Those are on lines 11 and 12. All of these values in the default config element used to be stored in the Android manifest file in Eclipse. Now you configure them in the build.gradle file. In Eclipse, there used to be a user interface to change these values when the values were in the manifest file. But in Android Studio, you just edit them in raw text. Pay close attention to which values have quotes and which don't, and follow that pattern carefully. For example, the version code is always an integer. There are no quotes around that value. But the version name is a string, and so there are quotes around the value. Up at the top, there's a Build Tools version. This value must match a version of the build tools that you have installed. And you can check that through the SDK Manager, selecting Tools, Android, SDK Manager. Notice that I only have one version of the Android SDK build tools installed, version 21.1.2, and therefore all projects that I work on must have that value for the build tools in the Gradle build file. It is possible, though, to have more than one version of the build tools installed, and so if you're working on this course and there's a more recent version that's available in your copy of Android Studio, you can avoid a lot of rebuilding problems by also downloading 21.1.2. I'll close the SDK Manager and return to the build file. When you create a brand new project, the dependencies element will always have two compile directives. One, at line 23 here, referring to jar files in the libs folder, and one referring to the support library. The purpose of the libs folder is to include jar files as a part of your app's class path. However, in real practice, you have to copy the jar file into that location and then explicitly add it as a library. You'll also have one or more dependencies for Android support libraries. You must have the support repository installed as well, and once again, you can check that through the SDK Manager. So these are some of the files that you typically work with in configuring your Android Studio project. The local.properties file to configure your SDK location, the Gradle.properties file to manage the Gradle build process, and the two Gradle build scripts. The Android manifest file is an XML file that describes the app to the operating system and the virtual machine. The name of the file is always the same, Android manifest.xml. You can find it in a few ways. In the project window, you can go to the project view and then drill down to the app module, and from there to source, and then the main folder, where your app's code and resources are stored. That's the physical location of the file. You can also switch to the Android view, and you'll find Android manifest.xml in a virtual folder named manifests. Or you can press Shift twice and use Android Studio's Search Everywhere feature and type Android manifest, and you'll find it. In Eclipse with the Android developer tools, there was a graphical interface for managing the manifest. That hasn't been recreated in Android Studio, so now we just have to edit the XML file manually. The XML file's root element is always named manifest, and it contains a child element named application. The manifest file starts with a namespace declaration, labeled with XMLNS:\Android, and it always points to exactly the same string, ending with APK res Android. All of the attributes that are used throughout the XML file then use that prefix. So for example, attributes like allow backup, icon, label, and theme are all members of that namespace. The root element, the manifest element, has an attribute named package, listed here on line 3. The package is used as the app's unique identifier, as I've mentioned previously, and it does have to be globally unique. Typically, this is accomplished by using the organization or the developer's domain name in reverse domain notation. And the package that's listed here must match the application ID that's listed in the Gradle build file. And that value also has to match the default package where you place your Java classes. So in my virtual folder Java, I find packages that exactly match the package here. It is possible to change this default package and application ID and let Android Studio do most of the work for you. The best approach is to change the package name here in the package attribute using Android Studio's refactoring capabilities. I'll click into the string and then press Shift F6, and I'll see an extensive message telling me everything that would change. I won't make that change here, but I encourage you to try it out on a throwaway project, a project that you're not working on as a production app. Android apps sometimes need permissions that allow them to take certain actions. You ask for permissions by adding an element to the manifest file named uses permission, and it's placed as a child of the manifest element, the root element. So for example, let's say that I wanted this app to be able to check Wi-Fi status. I'll place the cursor after the application element, and then I'll type the beginning of another element, starting with the word uses. Android Studio offers a few possibilities, and I'll choose Uses Permission. I immediately see a list of available permissions. On my screen, Access Wi-Fi State appeared at the top because I've previously selected it. If you haven't done that before on your system, you might have to scroll around to find it. But I'll select it, and then I'll close the tag with / and a greater than character. Now, when I package and upload my app to the App Store, the App Store will then notify the user of permissions that are being requested as the app is being installed, and they have an opportunity to stop the installation. You can add as many permissions to an app as you need to, but you should only add permissions that your app actually needs. And in this example, once I've added the permission, I could then add Java code to my app that inspects the device's Wi-Fi status and listens for events that are broadcast when that state changes. The application element is another child of the root folder. It describes certain resources. So for example, the icon is set to a string of mipmap/ic_launcher. The @ character followed by a string indicates the name of the resources folder where the content is stored. So the icon attribute is pointing to the files that are under mipmap, and then there are 4 different versions of the launcher icon, one for each of 4 pixel density buckets that are defined in a brand new Android project. In older Android projects, the launcher icon was in the drawable subfolders. In newer projects, it's placed in the mipmap subfolder. Next is the label attribute. You'll see that there's a label at the application level, but there's also one at the activity level. The one at the activity level is the one the user actually sees. When an activity comes to the screen, by default, this label will be displayed in the title bar of the activity or screen. And the launcher activities label determines what shows up on the Android device's home screen to describe the app to the user. These strings look like raw strings, but if you move your cursor over them, you'll see a little help pop up that indicates that this is really a resource. It says @string / app_name. If you want to change this string, jump to the strings.xml file. First, I'll double-click on that string, and that shows what's actually in the file. Then I'll hold down the Control key on Windows or the Command key on Mac, and I'll click that string. And that opens the file strings.xml. And I can change this. So for example, in this beginning file, my app name was Project Structure, because I'd copied this project from a previous project and I hadn't changed the app name. So here I'll change it to App Manifest. I'll save that change, and then I'll run the app. When I click the Run button, Android Studio checks for any connected devices. I don't have one connected right now, so I'll launch a new emulator based on the Nexus 5. Once the emulator opens, I see the app appear, and I see my new string appear at the top of the activity. I'll go back to the home screen, and then to the app list. I'll close this prompt, and I'll see my app appear here, and when I drag and drop the app icon onto the home screen, I see exactly the same string. So whenever you have a reference to a string in the app manifest file, it's recommended that you use a string resource and not a raw string. Finally, there's the activity element. Each screen in an app is known as an activity, and each activity has to be registered with the application through the application manifest file. The activity name is the fully qualified name of the equivalent Java class. The name attribute points to the name of the Java class that controls this activity. To jump to that Java class, Control or Command click, and that'll take you to the Java class that controls the activity's behavior. Going back to the manifest file, if you see a single dot here, that's the equivalent of the default package. So you could declare each activity with the complete package. I'll go up here and copy the package, and then I'll paste it down here before the dot, or you can simply use the dot. The first activity that opens when you open the app is called the launcher activity, and it's defined through something called an intent filter. The manifest file is where you define intent filters that indicate when an activity should open or offer its services. An intent filter's action being set to main and category set to launcher means that this is the first activity that the user sees. You can also use intent filters to open activities from apps when other apps ask for help. For example, when an app wants to share data with some app on a device that can handle that particular kind of data. So that's a look at what goes into the manifest file. As I mentioned previously, the manifest file doesn't contain everything about the app, as it did in older versions of Android when they were being developed with Eclipse and the Android developer tools. An app's configuration is now split between Gradle Script files and the app manifest. If you're working with Android Studio, you'll need to understand which configuration items go in which file. Every Android project has a resources folder. You can find the physical location of the resources folder under the project root. In the project resources, I'll go to the project window and choose the project view. Then I'll drill down to the app module, to source, main, and there's the resources folder. It's a little bit easier with the Android view, where the resources folder is shown as a direct child of the app module. When you create a brand new Android project, it'll minimally have the following subfolders: Drawable, for graphical resources such as photos; Layout, where you'll find XML files that define the appearance of screens or activities; Menu, where you define your menus and action bar items; Mipmap, which is where your launcher icons are placed by default; and Values, where you'll find a few different XML files that define strings, dimensions, and styles. There are many other kinds of resources you can create, though. Let's say, for example, that you wanted to define your own custom color and then use that color throughout your app. A color is a resource, and to define a color, you define it in its own file. Now, you could figure out how to do this manually, creating the file and giving it the right name and placing it in the right directory, but Android Studio can help you. So I'll go to the menu and choose File, New. Then, because I had already selected the resources folder in the background, the first item in the list is Android Resource File. That takes me to a dialog where I'm going to define the type of resource I'm creating. I'll pull down the list and I'll choose Color, and by default, it'll go in a subdirectory of the resources folder named Color. Then I'll assign the file name. The file name will become the resource ID, so you have to follow resource ID naming conventions, all lowercase, no spaces, and no special characters. I'll set my file name as my_red.xml, and I'll click OK. That creates the file and creates the structure of the XML file with a root element named selector and the required namespace definition. The selector takes a child element named item. I'll start creating the tag, I'll type item and then press enter or return, and I'm prompted for the color I want to define. I see a number of predefined color IDs. Notice they start with @color, and as I scroll through, I get a preview of what those colors look like on the left side. But I'm going to use hexadecimal notation. I'll press escape to get rid of the preview, and then type #F00, which is just red. Then I'll move the cursor to the end of the line and type a slash, and that completes the tag. I'll press Ctrl or Command S to save my changes. Then I'll go to my activity layout. That's the file activity_main.xml in the layout folder. When I double click it, I see it in preview mode. Notice the color of the text. I'll select that text and I'll scroll down a bit to show all the different properties that are being defined for this text. The text color attribute is right here. I'll click into it to select it, and then I'll click the browsing icon. And that takes me to a list of all known color IDs. Many of these are a part of the SDK itself or a part of a theme that's connected to this project. But I'll scroll down to here, and I'll select my custom color, my_red and click OK. Now I'll look at the XML file in text mode and show that the text color has been assigned. But in design mode, I'll see that my text object is now red. I'll make that a bit larger. I'll make this change in text mode. I'll set the text size to 32 SP. I'll be talking about setting text values later, but for now, we just need to know that that will make the text larger. I'll come back to design mode, and there's the result. A text value that's presented in my custom color. I can put in as many text values in my app as I want that use that color resource. But then if I want to change that color, I can change it in the resource file and it'll be changed universally throughout the app. So that's an example of a kind of resource you might want to use in your Android apps. The types of resources that are available are described in the SDK documentation, and I'll be using many of these kinds of resources throughout the course.